Coming up next, ladies and gentlemen, we're honored to have with us Dr. Will Cavendish, Global Digital Services Leader from Arup, to share with us on the topic of digital innovation driving low-carbon development. Let's all put our hands together to welcome Will on stage. Welcome.
So it's a great pleasure to be here at the Digital Economy Summit 2023 to talk about digital innovation driving low carbon and nature development. When I look at the sector that I work in, the world of the built environment, we face really profound challenges looking out to 2050. We're going to have another 2 billion people on the planet. We're going to be able to meet their needs in an equitable way. We're going to have 2.5 billion more people living in cities than we have at the moment, cities that still need to be designed, built, operated. We already have about 80% of the buildings and infrastructure that we're going to need in that timetable. So we're going to need to get ever better at using it, cherishing it, replenishing it, reusing it. But also, we face the enormous challenges as a world of living within our planetary boundaries. We have already used 80% of the global carbon budget that will allow us to stay within 1.5 degrees temperature rise. And that's from a sector, the built environment, that contributes about 70% of our global carbon emissions on an annual basis. And we're increasingly facing a biodiversity crisis, a nature crisis, where we're overusing what the planet has made available to us with degraded wetlands, species extinction, forest loss, and a need to preserve and improve what we've got. Because of that, at every level, governments are acting at the global level, within mainland China, and of course here in Hong Kong, to limit global warming rises and cut dramatically carbon, aiming to, in China, peak before 2030 and reach carbon neutrality in 2060, 2050 here in Hong Kong. To preserve, to cherish and improve the nature that we already have, but of course also to develop growth and prosperity and common prosperity for all of our citizens, including here in Hong Kong, the development of traditional sectors and new sectors that we've been talking about this morning, and contribute to the prosperity of the Greater Bay Area. These are enormous challenges, and these government commitments are driving change in what we do. Thankfully, across a very wide range of activities, of project stages and areas, we're seeing new digital solutions developing that are allowing us to create a step change on the pathway to net zero, regenerating nature, while also crucially meeting human needs and supporting prosperity. Take, for example, the ability to use digital tools, digital techniques, and digital technologies to develop lower carbon cities, lower carbon planning and design of our cities and infrastructure, and a greener infrastructure too. Here's an example of work that we, Arup, did in Shanghai to develop a drainage master plan for Shanghai. Shanghai, a city troubled by flooding, by flash flooding, by hurricanes, which knocks out businesses, undermines the city infrastructure. The traditional approach to doing that would be to build very significant concrete infrastructure under the city to take water from where it lands to where it needs to go. We decided to do something different. We used the power of artificial intelligence, machine learning, to train our systems to identify micro features of the landscape in Shanghai that allowed our urban designers and our planners to develop nature-based solutions to tackle this infrastructure design and planning problem. Small-scale green catchment areas, small riverine runoff areas, combined with traditional infrastructure to improve significantly the development and delivery of that water infrastructure. The solution, based in digital technologies, was 30% cheaper. It used 30% less carbon, but it also contributed to a better environment, a better microclimate, and a better city. And we've been extending that globally to 10 other cities to show that the capacity of digital solutions and tools to design sponge cities, which are better able to deal with flooding, better able to deal with climate resilience, and support prosperity, is very significant. We can use those same tools, those same techniques, to design our interventions to promote nature in a better way. So take a city like Tirana in Albania, suffers very strongly from urban heat island effects, very strong heat in the summer, very significant air pollution problems, very little ability to capture air pollution in the city. And there's not much for families and people to do in terms of amenity, places to relax and to be together. So we're using these tools and techniques to design an orbital forest around Tirana, using our understanding of the micro features of the landscape, the power of satellite data, and the power of machine learning to create an orbital forest that will reduce the heat in the city. It will reduce the air quality problems. It'll improve the quality of air. It will generate greater prosperity in the city, and it'll give people and families places to go. Equally, we face increasing challenges when it comes to the design of new buildings. New people designing new buildings want them to be significant in size. They want them to be able to support solar PV generation. They want to minimize shading. They want to minimize wind effects. But they also want those buildings to be low carbon, and they want them to start contributing to the replenishment of nature. This is where digital tools like generative algorithms can be so powerful in allowing us to achieve buildings that deliver all of those outcomes simultaneously. So whether it's using passive heating methods, bioclimatic design, natural ventilation principles, or in this case, designing a facade around the building that encourages insects to use and develop and procreate around the building, those are now possible using generative design techniques, solutions, digital solutions that just weren't available to us until recently. And this is allowing us to reduce significantly the carbon in our buildings, to improve the design of buildings and promote nature. And that's true because we're going to have to design and develop our buildings using much, much lower carbon materials. At the moment, cement, steel, glass all contribute significantly to the carbon footprint of our buildings. Again, digital tools, digital techniques allow us to design our buildings in a different way. Here's an example of a high-rise building. It's a 12-story building that's been designed with timber and steel rather than concrete and steel, only possible because of the digital structural modeling that we can now deploy at scale to understand the stresses and strains that are going to exist in that building and how we can use new materials to develop high-rise buildings in a way we were never able to previously. In this case, achieving an embodied carbon reduction of 51%, very dramatic reductions in the embodied carbon from a building. And equally, in the other case, using wholly new materials in the inside of buildings, again, to design and deliver the buildings that we want in a way that's compatible with the carbon reductions that we're going to need to achieve. There are some areas which are going to need wholesale transformation if they're going to survive and thrive in a low-carbon era, and the energy system is a classic one. The energy system of the future is going to need to be renewable, it's going to need to be intermittent, it's going to need to be real-time, it's going to need to be dynamic, it's going to need to be very different from the systems that there is today. This is a sector in which digital tools, digital infrastructure, is absolutely fundamental to achieving the pathway to net zero that we need in our society. And here's an example where digital twins provide us with a fantastic capability and a tool to be able to simulate and operationalize the transition of energy grids and energy networks from the ones we've inherited to the ones that we're going to need in order to deliver our low-carbon future. So in the United Kingdom, Arup is working with the national grid to develop the first digital twin, virtual twin, of the entire energy network to allow the grid operator to develop, simulate, and deploy the grid of the future. So again, digital twins as a technology absolutely central to the development and delivery of a low-carbon future. And in other areas too, like the conversion of gas networks to hydrogen. digital twins allowing us to plan, sequence, and deliver that in a way we weren't able to do previously. Likewise, the transport sector is needing to fundamentally transform and is facing a proliferation of new technologies, connected vehicles, hydrogen vehicles, electric vehicles, which are changing the transport system, around us as we live and breathe. And here again, we're going to need, and we can deploy digital tools and digital solutions in order to support and enable that transition to happen. Transport systems need to meet the needs of people. They need to make sure that public investments in transport are sufficiently well funded and delivered. But they also need to support new technologies, the transition to electric vehicles and the transition to more intelligent mobility. Here, the power of what are called agent-based modelings, models that are rooted in the individual behaviours of real people and real families that understand what they need, where they want to go, when they want to go, and how they want to move around. Those tools are absolutely fundamental to supporting the transition in the transport sector that we need to enable and need to make happen. And they allow us to deliver new insights and new approaches to transport than we've had in the past, and in particular, develop and deliver the transition to electric vehicles, which are going to be a pervasive technology of the future. That transition is enabled and augmented by the digital tools and capabilities that we have, the advanced modeling, the understanding of data, the use of sophisticated algorithms and machine learning in order to plan and predict that entire technology. And likewise, here in Hong Kong. I can't hear any sound on this.
Spatial data infrastructure is to facilitate opening up and sharing of government geospatial data. Kowloon East, as the first project area of 3D digital map, undertakes a vital role in experimental research and pilot demonstrations. Compared with traditional maps, the 3D digital map can provide more accurate and abundantly better spatial data.
So 3D city maps, spatial visualizations enable in a city like Hong Kong to plan, deliver urban infrastructure in a way that we weren't able to do before. We also need to tackle the challenge of our existing buildings. We need to decarbonize our buildings, and we need to make them more resilient to climate. Again, digital tools and techniques and the power of data are going to allow us to do that in a way we haven't been able to do previously. In particular, looking at climate resilience. Many of our buildings and many of our buildings portfolios are going to be under threat due to the combination of changes that our climate is going to bring about. Different levels of heat, different rainfall levels, enhanced hurricanes, in some cases enhanced seismic activity. We can bring together the data and the predictions of our climate models with our understanding and our digital understanding of our building stock at quite a detailed level in order to provide insight that we've never been able to before about the resilience threats to building portfolios and how we can cost effectively ensure that our existing building stock is more able to deal with and survive and be more resilient in the future than it is at the present. And likewise, we need to do the same for carbon. For in many parts of the world, enhanced carbon disclosure rules like TCFD threaten to make entire buildings stranded assets that will be unusable under the new carbon regulations. So again, digital tools, digital techniques, and the power of data are allowing us to understand the carbon footprint of buildings and provide real and practical examples of how buildings can be decarbonized in a cost-effective way that are going to allow them to continue as usable assets into the future as carbon rules and disclosure rules get more and more strict. In some parts of the world, 50% of the building stock is threatened with becoming a stranded asset in the near future because of the need to comply with carbon regulations. That is a profound challenge to our prosperity. That's a profound challenge to the value of our existing assets. Again, our digital tools, our techniques, things like the CRISP tool that we've been developing, allowing us to provide advice and guidance about how we can maintain and improve the performance of our building stock. Let me move on then to the need to actually develop and use our existing assets better. As I mentioned before, much of what we need is already built, and we're going to need to develop and reuse those assets in a way we haven't done previously. Here again, the power of machine learning and data is allowing us to understand the state of our existing assets and improve them and improve their life over a much longer period than was expected. An example here is offshore wind. Offshore wind farms are often designed with a 20-year life. That life is based on an engineering judgment. For the first time, we've started to put sensors on offshore wind foundations, and we're able to predict the remaining lifetime of every single weld on an offshore wind farm to safely extend the life of that asset much, much further than it was traditionally assessed. And we can do the same for complicated and important assets like long-span bridges, of which there are many here in Hong Kong, expected to last 40 or 50 years. We can now use sensors, accelerometers, strain gauges, the power of data to properly understand whether that asset is still performing, whether it's still safe, and what we can do to structurally repair and extend the life of that asset. That is digital capabilities, that is algorithms, and that is machine learning, unlocking enormous value to our infrastructure. The value of an infrastructure asset that is kept and maintained and extended is huge compared to the cost of scrapping it and rebuilding from scratch. So the new world of data, the new world of structural modeling, and the new world of machine learning is allowing us to provide significant value to our existing infrastructure. And the same goes for refurbishing and repurposing the buildings that we have. Very often, buildings are torn down and replaced because people are uncertain about whether that building is still structurally stable, whether it's still fit for purpose. Very, very advanced methods can now be used to tackle that problem. We can deploy machine learning on things like vibration analysis to understand the strength of an existing structure. Has the concrete started to crack? Is it structurally safe? If we renovated the building, would it still stand up? If we introduced and opened up an asset completely, would it still survive? Those tools are now available to us in a way they weren't 5 years ago or 10 years ago, offering an enormous economic opportunity, a business opportunity, but also an opportunity to keep and preserve what we already have, and crucially to avoid the enormous embodied carbon that would be affected if we tore down these structures and rebuilt them from scratch. So there are many, many examples of how digital is allowing us to meet the low carbon objectives that we now have, the transformation of sectors that's required to happen in a way that we were never able to do previously. And we in Arup believe that in the built environment, these 6 technologies are going to be really crucial to it. Artificial intelligence and machine learning, absolutely at the heart of everything we're doing, using the power of data and advanced analytics in ways we weren't able to do previously. The availability of data from cheap sensors, drones, and satellite technology, allowing us to analyze, understand cities and districts in a way that we weren't able to do previously. Digital twins as a way of understanding and tracking and monitoring the assets and systems that we have to improve them, operationalize them, and deploy them in a better way. The power of the underpinnings of Internet of Things, 5G networks, and cloud computing, absolutely vital for the new digital economy and the built environment that we need. Generative design, the ability for us to maximize and optimize simultaneously across the so many different objectives that we have. New capabilities in that area that we can deploy now in the built environment. And of course, robotics and automation, being able to do things that humans, it's not safe for them to do or can no longer do. But of course, the truth is that we've only just started in the built environment, and there's a long way to go. And the countries, the cities, and the companies that take advantage of these opportunities will, I believe, have very, very significant business opportunities and prosperity opportunities for growth, both in their own areas and globally as well, because all of these challenges are being faced around the world. So, around the world, and here in China and Hong Kong, in the built environment, we need to meet human needs and we need to promote prosperity. Fundamental. We need to cut carbon and we need to secure climate resilience. And increasingly, we need to protect and enhance our natural environment. And so often, these objectives are seen as in conflict. We can't cut carbon and increase resilience because somehow resilience needs more stuff, cutting carbon needs less stuff. We can't cut carbon and promote prosperity because it means doing less. We can't protect our natural environment at the same time as meet human needs. These are all portrayed as trade-offs. They're so often seen in conflict. But examples from here and from around the world show that digital is going to be central to achieving all of those goals. Delivering prosperity, cutting carbon, saving our planet, meeting human needs. Digital is going to be absolutely the heart of all of those things. And I hope I've shown you some examples through this presentation of how new digital tools, new digital technologies, new digital advances are absolutely going to be at the heart of the economy of the future. Thank you very much.